Hello once again, welcome back to Electro Home. In this video, I will show how a proximity sensor works. A proximity sensor is a cheap sensor which you can buy for around 160 rupees. You can also make your own proximity sensor module with a simple circuit diagram. I have attached the circuit diagram in the description below. You can use the proximity sensor in different Arduino projects, and I have hacked an RC car with a proximity module and an Arduino microcontroller. Now this car will automatically change its direction when an obstacle is detected in front of the car or it hits a wall. I will also explain the working of this RC car. First of all, take a look at the proximity sensor module. In the proximity sensor module, there is a photodiode, an IR transmitter, couple of resistors for the transmitter and the photodiode, a potentiometer, LM358 comparator, indicator LED and connecting pins. When an obstacle is placed in front of the proximity sensor module, the IR beam coming from the IR transmitter hits the obstacle and reflects back to the photodiode. The voltage from the photodiode is directly proportional to the intensity of the infrared beam receiving at the photodiode. When the voltage from the photodiode increases the reference voltage set to the comparator, the output of the comparator triggers to a high value. The reference voltage can be set using this potentiometer. If the reference voltage is set to a very high value, then there is a chance for the comparator to remain in a low state. When it is too low, the comparator will remain in a high state. So carefully set the reference voltage at an optimum range using this potentiometer. Now just make a simple circuit which gives the basic idea of working of a proximity sensor. In this simple circuit, the LED triggers from low to high or high to low only when the proximity sensor detects an obstacle. Now add one more proximity sensor to the circuit and another LED also. Hope the working of the proximity sensor is clear. Now let's move on to the RC car and its hacking method. I found this toy car from my little brother's toy collection. He abandoned the car because he lost the remote control. I tried to make a new remote control for the car, but during the research for making a new remote control, I realized that there are so many other ways which can be used for controlling this car. If I can reproduce the signal that the actual remote control of this car sent to this receiver, I can control this car with a single pin in a microcontroller. For that, I studied the datasheet of the decoder IC present in this car circuit. It is TXM RX2, and from the datasheet, I realized certain code pulses are triggering each motion of the car. Then I created a code for the reproduction of signal pulses for motion of the car in all directions. I also added a proximity sensor to the car and updated the code for avoiding obstacles, which means whenever the proximity sensor detects an obstacle in front of the car triggers to a backward left motion for a few seconds and then start to move forward. One major thing which should be noticed while connecting the digispark microcontroller to the car circuit, the decoder IC requires only 2.5 volt at the data input pin, but the output from the digispark microcontroller is 5 volt. So add a voltage divider for reducing the voltage. I used two 10k resistors for reducing the 5 volt to a 2.5 volt. I have attached the datasheet of the decoder IC in the description below. The code is also included in the description.